we will start working on the robotics. And one of the most important things about robotics is therapeutic robotics. That's what we are going to talk about. So not robotics in general. So you have robotic prosthesis, which is upper and lower extremities. And then you have robotics that you can control with the brain. That's also prosthesis. And you have robots for surgery. And that's another thing that the physicians will do. But what we'd like to focus on is therapeutic robotics, which are the things that people are using in physical therapy clinics and occupational therapy clinics in order to provide therapeutic interventions for patients. So that's the goal of what we're going to be doing. We need to introduce the theory behind the advances, and we're going to look at 11 devices. And the idea is we're going to look at the companies and the devices. It has a lot of good information about what kind of products are there and if they are working or not, and how people are trying actually to assess the success of these devices. For each one of them, we'll talk about the description, the cost that's available as a public information, and then do we have anything demo or in service from vendors, other clinics who use the product, evidence. Now that's what matters the most, the efficacy, is it working or not? And that's something companies will hire you as biomedical engineers to test and to assess their product. And that's called research and development. We would like to see which team, in which state they're actually using it and why. And we will follow up with, see if we can search for vendors and see who is doing the next generation of these products. If you want to work with this, you'll be something called product engineer. So technology and rehabilitation, the most important thing is sensors. You would like to provide feedback and data that you can analyze later on. We would like to have the biofeedback, the feel, see, and hear, so that's all sensing. And we started working on a couple of them using the Arduino. But you will be designing special purpose sensors. That's the most important thing. And the thing that we care about is muscle activity, forces, moments, like in a sway, when you study swaying. You would like to look at linear and angular kinematics, which is position, velocity, and acceleration. Those are the things that we would like from you to assess. Here's the idea, is that you need to monitor progress and tracking outcomes and evidence of third-party payers. We can collect data, but we would like to present it in such a way that people can make sense of it. It has a clinical relevance. And that's where the interface comes in. So if you go to an ophthalmologist, right, they will show you a chart. If you did, the field of vision test, they will show you a chart where is your, cluster of, the dots that you've seen and where are the blind spots and that thing. Now, this is now translating data into a report that people can understand, and that's what we need to be able to do. So I'd like to look at these things. And now the evidence of third-party payers, who's going to pay for this? So let's say you developed a prosthetic device. How are we going to be working with health insurance companies to subsidize for this service? And remember at the beginning of the semester I told you need to have a rehabilitation plan, and then the physician or the physical therapist will decide which device and for how long and what are the outcomes that are going to be assessed. And then this could be provided for healthcare insurance and they will cover it for us. Is the technology relevant for society? And then motivation and engaging. And if from the ultrasound and electrical stimulation, we talked about how important compliance is, right? It'll be a big problem if people are not doing compliance. And then marketing tool. We're not going to talk about screening, but research. So companies will do marketing by saying, well, this University of Mount Union studied our, let's say, KT tape, right? And they found that the KT tape is good in limiting the rotation of the knee and reducing the risk factor for ACL tears, right? And we publish this as, as a research. They will use it as a marketing tool. And that's the thing that we would like to realize as engineers, that whatever you're doing in research, when you publish it, that's a marketing thing for that company, for the KT tape. Simulation in clinics, that's something you can develop a tool to do simulation, right? And we have something called simulation lab. If you go to the nursing department, they have all these simulators, baby simulators and big, adult simulators. So you can design things that you can do simulation, and that's a medical device. And that's another thing that you can work as in the field. Errorless learning, that's another thing. So what does that mean? That can you, let's say we have a subject and the subject is trying to learn a motor task, but you're using a lot of technologies to assess, right? So you're reducing the error of human errors. You're reducing the error that we are missing something. Does that make sense? So because you have data to compare, and that's quantification. So here's what you need to focus on in all the devices that we're going to cover. Adequate feedback. Are we getting data? And variability of practice. That's another thing. How are people using the tool? Is it versatile that can be used for multiple outcomes? And the design of learning situation. How would you teach the patient and actually the healthcare provider to use it? So those are the things that limiting actually the use of technology in the physical therapy clinics. So patients with motor dysfunction are totally dependent on the information concerning the outcome of the attempts to perform motor task. It's keep in mind that it's really hard for someone with disability to perform motor task repeatedly, right? So they need to make sure that whatever they're doing is giving them an outcome, a positive outcome. Those are other, speech, text or, contribution of people that say how important to have technology and how it will influence therapy and the psychology and all of these things. It's just an evidence that this is really important for us to look at. Yeah, and remember, all we care about physical communication and cognitive limitations. So it doesn't have to be only physical. It's not only human motion. So speech is communication is a problem. Cognitive, people with, any genetic disorder, that's another thing for us to look at. Chronic, progressive. So all of these things are important for, it's just an evidence of how technology can be useful. So those are the tools that we're going to be looking at. And again, we will look at the tool. I just want you to learn to know about it and then look at the evidence. Is it working or not? Now here's the thing. It's mixed. So companies will tell you, well, this is working for that, but 5 years later they will do another study and then someone will say, no, it's not working for that thing. And that's the problem in why this is not actually infiltrating the clinical setup, because of the complex, the variations. Now here's the thing. If you have a tool and you have, how would you say that this tool is effective? You have 10 publications. If you have only one publication, that's a no-no, right? 2 publications, still very low. You need to have 5 and more. But even those 5, you need to have at least 70 to 80% of them giving you positive outcomes. Now here's the dilemma with research. Usually people, if the people don't publish unless it is actually a positive outcome. So even the data that's published is actually skewed. Yeah, because if someone gets no results, they're not going to publish that. Or they have a negative effect, they're not going to publish it. So that's another thing that we question actually the data in the research. And that's why you need to make sure that you develop your own data set. And that's what I do. I always develop my own data set, like ACL, movement, jumping, and then I assess from this data set, not from someone else's data set. Make sense? So let me show you a couple of things. So we're going to touch base on most of all, I think all of those. But, so we have something called the Biodex balance system. So it's a platform for testing and training of static and dynamic standing balance. And that's important for elderly people, right? Because they lose balance and they fall. And if they fall and they break their hip, that's lethal. So we try to train them on balance. Now, it can do this, fall risk screening and training. So here's another thing. So they can bring a subject, they will stand on that device, it will do some movement, and they will tell you, well, you have high risk of falling and we need you to prescribe for you a cane or a wheelchair. What do you call the walker? Or a walker. And then based on this test, health insurance company need to cover that. You can do postural stability, clinical tests of sensing integration balance. So these things are clinical tests that people do actually in the clinic. Compare scores to age-dependent norms, chart progress over time, after physical therapy if there's an injury, and you can determine with which of 3 balance system options is points is relying on, the patient is relying on. So this is the device, right? The screening, the people are using it to screen someone with concussion, right? To see if their balance is off or not. Now, effective with, so those are, I think, hold on. Can you check on your, what is CVA? I need this abbreviation. I don't want to speculate. So define CVA. There you go. That's a concussion, right? That's what they call it. Yeah. So one of them. So it's cerebral vascular accident. That's what they call it? Yes, right. Makes sense. And so the cost is 12,000, very common in clinics. And there is a video that you can watch of how people are actually testing that device, right? And that's the YouTube. Yeah, there is also biosway static device, which is, 5,000, and the Biodex is 10,000 training to do that. And what you will see in these tests is something like this. It will show you, it will track for you this, where is the center of mass of the subject, bless you, the center of mass of the subject. And then there's a lot of things that you can add. You have 6 training models, and these are the things that you can measure with it, and the tests that you can do. And all these tests are actually standardized tests, which means that if you want to work in this field, you need to know them to be able to communicate with physical therapists on that thing. Does it make sense? Right. I think this is a cool tool, but the most important thing about the tool is the data and the sensor, the sensing data. And if you, let's say, are collecting data, you need to write a program to show these results. Make sense? With the interface and all of these things. So that's something you can work with, and you can improve and analyze on these things. Make sense? So that's one of them. Remember, this is a therapeutic device or robotic. That's how we look at it. Because it does, so robotics, we have an idea that it's always, things that are moving. Yes, but automation is part of robotics, right? And that's what we are looking at here. I'm going down. All right. Okay, we're good with this one. So the Biodex balance system, and you can search the company, and I think they're still working. They're still in the market. Now, there is another company or a product, the NeuroMove, and it was cleared in 2001 by the FDA to be used. So that's also an FDA-approved product. So it is used for stroke rehabilitation by muscle re-education, and re-education means training. So what do we do that? So if you say that someone has a spinal cord injury, right, and we need to continuously keep helping that subject doing repetitive movement so that the movement will reprogram the pathways to go to the brain. We have the afferent and afferent pathways of the nerves. If you keep repeating a movement, you are reprogramming actually the pathways. So if there's an injury, it can go the other way. And that's what we mean by re-education, the muscles, by reprogramming the pathways of the nerves, right? It's good for relaxation of muscle spasm and spasticity. And spasticity is the high tone, right, of muscle, high contraction of tone. And that's an indication, let's say, you can see this mostly in children with cerebral palsy, right? That's the spasticity. Prevention of retardation of disuse atrophy, which means that, so let's say someone is sitting on the wheelchair for a long period of time and they're not doing movement. You can use this device to continuously stimulate the muscles so that you are actually limiting atrophy. Remember, our body is optimized. If you're not using bone or muscles, the body will do atrophy and use the proteins in somewhere else. Increase local blood circulation and maintain or increase the range of motion. So all of these have been actually, there was evidence provided for the FDA to approve this device to do that. So that's based on electrical stimulation. And you can have another version with ultrasound stimulation. Remember we said if it's bone, ultrasound is better than electrical in creating osseous tissue, which is bone. But the electrical stimulation is better in creating cartilage and cell proliferation. So it depends on how you're going to be using that. So how does this work? So there is a video for it. Detects attempts below where trace movements are visible, and then distinguish between regular muscle activities and muscle tone and real attempts. So, and also it's increase when you try to move your hand, it detects the EMG, right? Now, if that EMG or muscle tone is above a threshold, it's actually going to give you more electrical stimulation so that it can continue the movement. So that's actually how it works. So when real attempt is detected, the unit rewards the patient with muscle contraction. So it gives you more stimulation, electrical stimulation, so that you are actually contracting more with that thing. You have visual and sensory feedback for that device is an important element of relearning the movement. And you don't need someone to keep holding a patient's hand and moving it. If the patient's trying to move, this will give you more contraction. Very motivating. They make a difference where previously they had no indication of their attempt. So that's another thing for the feedback for the patient. So the patient were trying to move their hand, but they can't, they feel discouraged. But now because of this stimulation, it helps them see, oh, I am moving my hand with the help of this device. Does that make sense? So this is another approach actually, instead of direct stimulation, is detecting to a level and then moving that. I think this model was all or nothing, right? So once it detects a threshold, it just moves all the way, right? And you can have it on only the big muscle groups to do the stimulation. From an engineering point of view, we can do this. These companies, when it comes to business models, they don't want to have a lot of variations for the FDA to approve. So they try to do the simplest way in order to get their product in the market. That's something to keep in mind. Yes, you want to avoid complicating at the beginning, complicating the process of how that works. And that's the tricky thing about our devices, is that the regulations is really, and it takes a lot of money and time. So that's why they're trying to simplify it. Well, can I perform one task? If it's working, everybody's happy. So it should be good. Now, concentration focus is the key to achieve better control. Does not work on confused or cognitively low patient. And that's another problem. They need to, so if your device is working, that's good, but you need to tell the FDA the limitations of the device. So here, they've tried using this device with people who are, confused and they have awareness problem in their surroundings, right? That does not work for them because they don't know what they're doing. So that's another thing you need to keep that in mind. And they need to be used 1 to 3 times a day for 20 minutes, and longer intervals not come because people are not going to keep doing it, right? It's the motivation to do that. It's very effective for spastic, flaccid extremities, which means that it's stiff, no? The other way, relaxed. Okay, and the International Functional Electrical Stimulation Society is the society that actually is putting the standards for this type of devices. And that, again, remember, we need to have always a society that puts standards. And we talked that the standards are not mandatory, but someone has to do some, voluntary standardization. Now, here's the thing. With these devices, if you want to increase, let's say, the interval so that people can use it more, you need to add something else to it, which is gaming, right? So that's another thing that I like to add to a lot of these technologies. Can we add some sort of gaming or, visual effects with these things? Remember, even, gym equipment now, they have big screens and they try to have, videos with so we have the technology, but we need to add this in order to increase the time interval in doing. Does it make sense? Now, so we talked about it. We know that this does exist. Now, what are the clinical studies and evidence? So there is classically backed by biofeedback principles. So people publish studies that say that there is a positive outcome if you have feedback. So the patient is trying to move, and then the patient is seeing the muscle contracting because of that. So that's a feedback, right? Because you're sensing it as well as you're seeing it. So there is a lot of publications say, well, patients who can see the feedback or feel the feedback, that's good for them. And that's another thing to keep in mind when we talk about rehabilitation engineering, is that no matter what device, so for example, the chair and stuff, when you're moving the chair, you're seeing the movement, the motion. So that feedback is positive for patients. Now, most of the study included patients between 6 months and 14 years post-stroke, right? Subjects were motivated and cognitively intact, and the findings were improvement were in the form of improved strength, improved range of motion, reduced spasticity and tone, more flexibility, and motor capability in general, right? So that's good, that's positive. Regular therapy and electrical stimulation was less than half as effective. So electrical stimulation is just stimulating the muscles with electrical signals just to contract the muscle, but not to use it to have a threshold and to move that. So these two things were half as effective as this device, meaning that this is really good. And that's why the FDA approved that device. Make sense with this? It's a form of feedback, so it should be positive to show them that they are improving. And that's what I like to see in all physical therapy clinics and occupational therapy clinics, that, well, that's your EMG before, this is how much energy, this is how much force, this is how much frequency, and now look where you are. So that's good. But this is interactive and providing feedback. So it's, but you're right, any feedback will be positive. And patients will be motivated. So every time they feel they're progressing, that's really positive. But I hate when someone says, oh, you're good, you can go home. You need to show me something to take home and look at. Make sense? Yeah, but this device was really, really important, and that's why we want to talk about it. And there's a lot of publications. So these are the publications for that device. I know this is old, but they have, I think 2000, after 2010, they have more actually publications about this. Make sense, right? Yes. And you can go and you can search online and do, see if there's anything that is published recently. Do you want to do a quick search? So search for, go to scholar.google.com and search if you can find anything that is using, I don't want to go back here because it's going to mess up the recording. Can you check the name of the device and see if you can find, and see they don't put the name of the device in the title. So electromagnetically triggered electrical muscle stimulation. So let's say NeuroMove analytical stimulation and electrical stimulation. You put this electromyography triggered because the EMG is the one that we are measuring, and if it's above the threshold, it will trigger stimulation, right? So that's the key thing: electromyography triggered stimulation. So if you want to look at this, you look at the publications and see. I will always check for the name of the trademark, the trading name for that device, and go to the acknowledgement. If they're supporting, they will say that this project or research was funded in part by, Xenex or Xenex. That's the company that do it. Make sense? We're good with that. But it's really a cool thing, and you can see that this electromyography triggered stimulation is getting attention because people are using it in multiple publications. Make sense? Good. So you look at the EMG, and you can for the EMG, you can look at the maximum peak, the voltage. You can look at the frequencies, and you can look at the energy, and the energy, which is the area under the curve of the EMG. So you can take these signals and you can trigger them. Okay, now the unity price is about 5,000, 6,000. There's a 90% discount. This is old. A patient can lease this for $99 a month. The health insurance companies will pay part of this. They're not going to cover the whole thing. But if it's written in the plan, in the rehabilitation plan, that should be okay. Yes, and so the thing is that this should be, when you go to physical therapy, people will be receiving interventions, right? This should be part of one of the tools in the physical therapy clinic. And then they can charge the patient or the health insurance rather than the patient buying it and putting it home. But the thing is that they need to go do this 3 times a day, 1 to 3 times a day, and that's a limiting factor. So having it at home is much more convenient, but you need to make sure that it's used. Any place you would like to have, training, this should be something. And remember, guys, we have the technology, so actually we can do it ourselves here in the lab. You can measure EMG, put it on an Arduino above a threshold, it's a frequency, or if it's just the amplitude, and you can send a signal to trigger contraction. Now, it doesn't. You've seen it's capacitive, so it's not direct. So we're not putting wires inside the body, so it could be on the skin surface, and you can do this. And it should be getting cheaper and cheaper. But you need to know the frequencies and that you're triggering the muscle with. Yeah, but I agree. It should be actually and that's the problem that I see in physical therapy and occupational therapy. These things should be in the clinic, but they don't enter. All what they have is massage tables and balls and weight dumbbells and stuff. So everywhere I go to the clinics, I don't see the technology in these technologies, which is sad actually, because we can have this there. So if you're interested in doing this, consider doing a doctor of physical therapy. You can be practicing. You open your business, and after you do doctor of physical therapy, you will do master in business administration, and you run your practice. You don't do it yourself, but you run a technology driven clinic, and then you should be fine. I know a lot of nurses actually who are doing. I was told that they are now doing their master in business administration because they want to run the practice, not just do the practice, especially for nursery homes. So that's another career pathway that you can take. It will take more time, but actually you can do doctor of physical therapy and MBA online. So you'll be done in 2 to 3 years with 2 more degrees, and then you can really run a practice. Yes, I agree. But it's you can do that. Because I feel they need help. I think we need more people who can change the practice in physical therapy and occupational therapy. And I'm happy that Mount Union is now developing a doctor of occupational therapy program. So we are starting a master's in nursing and the doctoral of occupational therapy alongside the occupational physical therapy. And by the way, this could be nice. Mount Union got 800,000 US dollar in grants to fund people to study doctor of physical therapy and nursing. So they will pay for your tuition as long as you work in Ohio and you focus on problems in Ohio. So they will fund. What's that? It's not long. I don't think it's 1 or 2 years. But you need to work on projects that are related to the problems that Ohio is saying that this is really actually. Yeah, they will give you, just like the scholarship, the program in Cleveland State University. I was happy that Mount Union got it. So Dean Mader, the Dean of the Health Sciences, she got the grant and she wrote it and she got it, 800,000. So that's cool. That's really good. We need people to think differently about this. We're good with the first two. Now the third one is called Smart Balance Master, and that's NeuroCom. That's the company. Can you search if this company is still up? I think they are up, but their devices is not as effective as people think. Is it there still? No, NeuroCom. Yeah. I didn't have a lot high hopes from this device. But the smart balance is they're trying to it's the developer or the provider, or because it could be a distribution, the owner or the distributors. They're different things. So this is the distributor. Yeah. They'll focus only on multiple devices, and that's something actually to keep in mind when you're searching for jobs. You can work for the developer or you can work for the distributor. So there's two different things. So this Smart Balance Master, it has really, really controversial outcomes. So it's a moving platform for the posture analysis, and also called computerized dynamic posturography. The whole idea is that they would like to just make sure that they're collecting data from sensors and about the posture and giving that data for you, and to quantify balance, which is fine. So they have a multiple. Yeah, I remember they have a lot of different models, but they have assessment for sensory and voluntary motor control of balance with visual feedback. And the visual feedback is just seeing a dot that's moving, right? And you're trying to follow the dot. So the whole idea was based on the feedback. They're saying, well, we know how to use them to build a force plate, but if you're seeing where you're going, that's a good feedback. And then the later models, they start having more and more visual feedback for the patients to see what they're doing. So, and you can have it on stable or unstable support surface. This is a stable support surface, right? Because you have harnesses. So if you fall, it will hold you back. And you have also handles on the sides. It's a fall risk assessment and balance conditioning. And the thing is that this is moving, and but I think it's standing. It's not a treadmill. Now the latest technologies, and people are now interested in treadmills, because when you fall, you're not falling because you're standing. You're falling because as you walk or run, and that's much more effective way of doing this. I'm hoping to get funding to buy a treadmill with force sensing here in this lab. So hopefully we'll get that thing soon. So it's useful for a defined patient who could benefit from vestibular rehabilitation and which balance system is involved. It's movable force plate and surround with an EMG. You can have an EMG system that you can measure the muscle activity. Availability for demo. So I remember that they can send one for university, and you can keep it for 6 months as a demo, and then they will, if you want to buy it, you'll buy it. I think that's what Rutgers did actually. We got a couple of these when I was doing my PhD. Other clinics, it's fairly common, but I don't think the data is what we want it to be. So you can look at all of these here, the standardized assessment protocols from physical therapists. So this is something related to balance, all of these. You can go back to it. And then it can tell you the models that they have and which one can be assessed via which model, the one that they were doing. And that's a marketing strategy. I prefer to have one model and do all the tests or download the test, just like the iWorks, right? You have the iWorks and you can select whatever test you would like to do from it. So it's visual feedback or conventional balance training, by the physical therapist and regular therapy. Yeah, so that has a publication that was done in 2000 about this. No additional effects compared to traditional physical therapy. So that's Geiger found that in 2001. It makes no difference in this device. So impact on independence is unclear, and the result of 7 clinical trials indicate that providing feedback from force result in patients standing more evenly, but did not improve balance during active functional activities. And that's what I told you. So standing is not the problem. The problem is when you're moving. And this device is focusing only on standing. So it did not make a big difference for us. Nor it did improve the overall independence. And that was in 2009. What happened with these companies is that they will look at the evidence, but they will keep saying, well, we're going to improve based on that. We're going to add something else and something else. And that's why they ended up with a huge number of models for them. Still, 2006, no statistical significance effect in function. The function is balance. That's the most important thing. Only if you look at long-term effect, that's another thing that the FDA is hesitant, because you need to look at 3 clinical trials, safety, efficacy, and long-term safety. And that's the important thing. So efficacy on the long term, nobody studied this for years, periods of time. So dynamic balance function of patients in the visual feedback. We know that visual feedback is good, but for the balance, it didn't show a lot. Activity of daily living function in self-care and control also had significant improvement at 6 months follow-up, less improvement for locomotion or functional independence measures. It was good for people to do self-care, but that's motivation and that could be psychology, right? But for us, the functional independent measures, that is the key, those things. So the results showed that balance training was beneficial for patients after hemiplegic stroke. That's another study that showed, improvement for people with a specific medical condition, right? Now that cannot be universal. But still, they continued doing the models and working on those. So different types. For us as engineers, when I look at these, I will say, well, this company, at least I appreciate that they're using different technologies to build things, right? Now, is it effective? That's a different problem. But at least we have the technology and they're trying to come up with models. And at one point, one of them will actually, work and deliver what they're looking for. Now, trunk balance is the acute stage of stroke, is a functional outcome predictor. So that's another thing people are looking at as a predictor. Clinical examination of balance is done by in daily patient stroke patients, not usually done in a standardized and objective way. And that's another, again, keep telling you this. They're doing tests, but it's not standardized and not actually quantifiable. And that's a problem for them. Last thing, and we'll be done, correlate outcome measures scales with specific motor results such as walking speed. So that's what we need actually to do. Can we get this out of these devices? That's what technology is providing us and helping us. Make sense? So I will stop here and we'll continue quickly on the other devices Friday and not Friday, next week, because we have the lab. We good? Okay. Thank you guys. And I will share the video with all of this as well on G2L.